we've been looking at statistical procedures for drawing inferences or conclusions about the mean or average of a group of data. This video will walk us through a couple more practice problems just to make sure we've got the mechanics down. Here's the storyline. Your investment advisor has recommended 12 stocks. You want to know whether your advisor actually knows anything. You track the performance of those recommendations, and over the interval of the study, those recommended stocks had an average return of 14%, about a standard deviation of 42%. First question. What's a 95% confidence interval for the true population mean return for all recommendations from this advice? Not just these 12, but from all recommendations. Take a minute, set up your solution, find the confidence interval. Pause the video now, work out your solution, then unpause the video and check your work. It's a confidence interval, so it's going to be of the form best guess plus or minus some number of standard deviations. For these data, our best guess was the average return we got from our sample, which was 14%. We're analyzing a mean, so the standard deviation will be the standard deviation of a mean, sigma over the square root of n. We had 12 data points. We don't know what sigma, the population standard deviation, is, but based upon our sample, we think it's around 42. Because we're estimating the standard deviation, because we're analyzing a mean, it's going to be students' t-distribution. We know the probability. We're looking for the cutoff score. So it's going to be an inverse function. 95% confidence means out in the two tails we'll have 5%. And we've got 11 degrees of freedom because there are 12 data points. Excel function tells us to go out 2.2 standard deviations from the middle. Do the arithmetic, 14 plus or minus 26.7. We don't know what long-term average return will be. It might be a pretty dismal minus 12%. It might be a very good plus 40%. There's just an awful lot of uncertainty at this point. Follow-on question. Overall market during this time made 8%. Can your advisor significantly outperform the market? In other words, this is a hypothesis test. Null hypothesis of no effect. His stocks just perform average. Versus alternative, his stocks do better than average in the long run. So we're testing population mean, Greek letter mu, whether that's 8% market average or better than 8%. Again, take a minute, set up the test statistic and p-value, work it through. Pause the video here, then in a minute unpause it and check your work. I knew you drew a picture. We got a mean of 8%. The sample averaged out at 14. We're looking for this area one-tailed. Observed minus expected over standard deviation. Observed a 14% return, expected 8%. Sigma over the square root of n, because that number is a mean, so we need the standard deviation of a mean. That works out to 0.495. In other words, we're only about half a standard deviation away from average. We want just the right tail. We know the cutoff score. We're looking for a probability That's a dist function, right tail, gives us a p-value of 0.315. For a large p-value, we do not reject the null hypothesis. We do not have reason to believe he can actually beat the market. Yeah, his sample result was a bit higher than market average, but there's so much uncertainty going on that it could very plausibly have simply been luck. So in summary, two basic inferential procedures, a confidence interval and a hypothesis test. We've noted that if we're analyzing proportions, we'll use a z-score, and this will be our standard deviation. If we're analyzing means, it will be a t-score, and this will be a standard deviation. But either way, we're fitting things into this basic framework.